Hello students, I am here with the chapter Mathematical Reasoning. Today I am teaching all the results and truth tables. After attending this class, you will definitely be able to solve the question. As you all know that we have one question from this chapter in JEE, and after attending this class, you will definitely attempt the question with correct option. So now look, what is written here? A statement. And the definition of statement is a statement is a sentence which is either true or false, but not both simultaneously. That means, and statement is denoted by small letter. That means if this is written that P, New Delhi is the capital of USA, then this is a statement because this is false. So if a sentence is true, then it is a statement. If sentence is false, then it is a statement. But if it is true and false simultaneously, then in that case, that is not a statement. So a sentence which is both true and false simultaneously is not a statement, but is called a paradox. Further, what is written here? No sentence can be called a statement if it is an exclamation. For example, oh God, you are great. And that is with this exclamation sign. So these types of sentences are not statement. An order or a request, for example, please close the door, is not a statement because this is a request. A question, for example, if I say, how old are you? So this is not a statement because this is a question. Sentences involving variable time such as today, tomorrow, yesterday, etc. For example, if I say today is Sunday, then this is not a statement. Involves variable places such as here, there, everywhere, etc. Involves pronouns such as he, she, they, etc. For example, she is beautiful is not a statement. Okay, there are few examples. First example is New Delhi is in India. This sentence is true, therefore this is a statement. Every rectangle is a square. This sentence is false, therefore again this is a statement. But if I say y plus 9 is equal to 7, so this varies. This is true and false simultaneously. Why? Because if I put y equal to minus 2, then this is true. But if I put y is equal to plus 2, then this is false. Therefore, this is not a statement. Okay. Now, what next? Now, what is written here? Truth values. Every sentence has two truth values. We have two truth values. If that sentence is, or if that statement is true, then we write true is denoted by small t, capital T, or 1. If it is false, then we denote it by small f, capital F, or 0. So these are truth values. Now, there are few connectives, and two of them are disjunction and conjunction. And disjunction is similar to union of sets chapter. Symbol for union is U. Here symbol for disjunction is V. The word which defines union is OR. Similarly, the word which defines disjunction is again OR. For example, if P statement is he is strong, and Q statement he is intelligent, then if this is written he is strong or he is intelligent, so we represent this by P disjunction Q. Okay, now Conjunction of this chapter is similar to intersection of chapter sets. The symbol for intersection is inverted U. Therefore, symbol for conjunction is inverted V. The word which defines intersection is and. Similarly, the word which defines conjunction is and. That means if this is written, he is strong and he is intelligent, then we denote it by P conjunction Q. I think it's clear to all of you. Now, what is compound statement? Two or more statements joined by connectives such as disjunction, conjunction, implication, biconditional, negation. These are few connectives. So if two or more statements are joined by connectives, then that statement is compound statement. Now, what is negation? The process of forming the contradictory of a given statement is called negation. It is denoted by either this symbol or by this symbol. Now, an example is written here that if you have to negate this statement, New Delhi is a city. So we can negate this statement in three ways, and these are three ways. First is, you can write that New Delhi is not a city. That means if negation means what? If your statement is yes, then make it no. If it is no, then make it yes. So here what is written? New Delhi is a city, and if we have to negate this, we write first, we write this as New Delhi is not a city. So therefore this is the first way to negate the given statement. Second way, we can also write that it is false, or you may write it is wrong. It is wrong. That New Delhi is a city. You may also negate this statement by writing it is not the case that New Delhi is a city. So these are three ways in which we can negate the statement. Now this is the truth table of negation. What we get from here, if the truth value of the statement is true, then its negation become false. And further, if we double negate it, that means negation of negation, this comes out to be true again. If we take P false, the negation of true will be true, and if we again negate it, we get this. So what we get from here, that double negation of a statement is the statement itself. Okay. Now what next is written here? Quantifiers. Quantifiers are phrases such as there exists, and the symbol for there exists is this. And another quantifier is for all, and symbol is this. This is the symbol for there exist, and this is the symbol for all. If in your statement there exists a or there exists at least is written and you have to negate it, then you have to go for all. That means you have to search the phrase for all in the option, or for every. Both are same. If in your statement for every is written, then you have to search for there exist a or there exist at least. So these two are negation of each other. There exist a is negation of for all, and for all is negation of there exist a, or there exist at least one. So if your statement is for every real number x, x minus 1 is positive, you have to negate this statement, and there are two components of this statement. First statement is for every real number, first part of the statement, and second is x minus 1 is positive. So you have to negate both of these statements. So negation of P is here. If they have written for every real number, we have to negate it. So negation there exists a real number. That means this is the negation of for every. There exists a real number x. So first component is negated here. Now second statement is x minus 1 is positive. The negation of x minus 1 is positive is x minus 1 is not positive. And 90% of you will write there exists a real number x, x minus 1 is negative. Negative is not the negation of positive because that does not contain 0. And if we have to negate, because 0 is neither positive nor negative, if you have to negate positive, you have to negate it by not positive. If there is written negative, then negation of negative is not negative. Negation of negative is not positive. Positive is not the negation of negative. Negation of negative is not negative. Okay, so this is how we negate the given statement. Now second example is written here. Let S be a non-empty subset of R. This is not the statement. Statement begins from here. Q such that there is a rational number x belongs to S such that x greater than 0. And you have to negate it. As I have told you that this is another symbol of negation. So we can negate. We have again two components of this statement. So first part is there is a rational number x belongs to S. So we negate it by, because we know that there is negation of there is for every. So we write here for every rational number x belongs to S such that, now the negation of this is if x greater than 0 is written, you write x less than equal to 0. So this is how we negate. Now next, conjunction is written here, and as I already told you that this is similar to intersection of the sets chapter, and symbol is inverted V, and the word which represent this conjunction is and. So and stands for conjunction, symbol is inverted V. Now what we have to keep in mind that in the truth table of conjunction, false will dominate. And what that means, that is, if I take the truth value of pt, that means true, q true, then true intersection, I'll say, instead of conjunction I'll say this intersection, t intersection t is t, q intersection p again means t intersection t, this is again t. But if the truth value of p is t and truth value of q is f, then t intersection f will become f, and f intersection t is again f. That means if one of the component of the compound statement is, at least one of the statement of the compound statement is false, your ultimate answer will be false, no matter whatever the truth values of the other components. So f, if the truth value of p, t is the truth value of q, then f intersection t is again false because one of the component is false, so answer will become false. True intersection f is again false, f intersection f is false, f intersection is f is false. So in this table false dominates. Okay, now what next is written here, tautology. This is very important. The compound statement which is true for any truth value of their component is called tautology. That means the ultimate answer, if that comes out to be true, then that is called a tautology. So after going through all operation, if your answer will become true, then that is tautology. The negation of tautology is called fallacy or contradiction. Now next is written disjunction. And what is disjunction? Another name of disjunction is alternation. As I already told you, that is similar to union of sets chapter. Symbol is here V, and the word that represent disjunction is or. So next I have written exclusive disjunction because there are two types of disjunction, but in JEE and in all the entrances we only use the table of this in exclusive disjunction only. Okay, and that is this symbol V. Now what is the truth table here? But you should know the difference between exclusive disjunction and inclusive disjunction. But we get the question of exclusive disjunction only in the entrances. So you have to keep in mind that in the truth table of exclusive disjunction, true will dominate. That means if the truth value of first statement is t, truth value of second statement is again t, then t union t is t. Commutative, that means this interchange, q union p, that is q union t is again t. If truth value of p is t and truth value of f p q is f, then true union f is true, f union true is again true. If one of the statement is true, your ultimate answer will be true. One of the statement of the component statement is true, if then your ultimate answer will become true. You have to keep in mind this. If p is f, q is t, then f union t is t because one of the statement is true, therefore my answer is true. True union f is again true. But the last row is if p is f, q is f, then f union f is f because here none of the statement is true. Therefore answer is f. F union f is f. So in this truth table, true dominates. So in the truth table of disjunction, true will dominate. Now what is written here? The if you have to learn what is the exclusive disjunction, then this is the simple this is the simple definition that you have to keep in mind, that the definition of exclusive disjunction is only one can happen at a time. So from this example you can learn this: an ice cream or a Pepsi is available with a thali. So this is an example of exclusive disjunction. And for inclusive disjunction, you have to keep in mind that both can happen at a time, and the symbol for inclusive disjunction is either this or this. So example is a student who has taken bio or chemistry can apply for MSc microbiology. If a student has both the subject, then again he can apply for MSc microbiology. So that means both can happen at a time. Now the truth table of this is, just learn this line, that unlike cases conclude to true, unlike cases conclude to false. That means unlike means true false or false true. For this my answer will be true, and for like cases means true true, similar, like, and ff. So this is the truth table, true true, like case, therefore my answer is false. True inclusive disjunction true, then again my answer is false because like. Now true false unlike case, so true inclusive disjunction false, my answer is true. Why? Because for unlike case my answer is true. False inclusive disjunction true is again true. False inclusive disjunction false, answer is false because for like case my answer is false. False inclusive disjunction false is again false. So this is the truth table for inclusive disjunction. Now next, what is written here? Logical equivalence. What does that mean? Two statements are said to be logically equivalent or equal if they have identical truth values represented by, and that is logical equivalence can be written as P if and only if Q, P equal to Q, and this is another symbol of logical equivalence. Okay, if you have two component statements and both will give answer true, that means they are giving the same truth value, then that means those two component state or compound statements are logically equivalent. So if two compound statements or a statement gives the same truth value, then in that case they are said to be logically equivalent. Now what is written here? Implication or conditional, and symbol for implication is this, or by this. But very important note is written here. This is very important point. What is that? Whenever you get the symbol, the first step is you have to replace this by this symbol, because all the properties holds in this chapter only on disjunction and conjunction. There is no property which will use implication sign. So first of all, you have to change this symbol by this disjunction. So whenever P implication Q is written, you have to replace that by negation of P union Q. Then only you can solve that question using the properties. So there are 6 ways in which we can convert this P implies Q statement. That means, just check this example. If P is written he is strong and Q is he is intelligent. So how do we read this? We read that he is strong implies he is intelligent. Using the first way, that is if P then Q, I can read this as if he is strong, then he is intelligent. Using the second method, Q if P, I can change this, he is intelligent if he is strong. So this is how we can change this P implies Q in 6 ways, and you should know all the 6 ways so that you can take the correct option. But the most important thing is the truth table of P implication Q, and for that you must keep in mind that in this truth table again true will dominate and only one answer will be false, and that is when true implies false, then your answer will be false. That means if first statement is true and after the sign of implication second statement is false, then my answer is false, otherwise it will always remain true. Now check this truth table. If P has truth value T, Q, T, that means true implies true will remain true. Q implies P, that is again true implies true, answer is true. But if P is true, Q is F, then true implies false. P implies Q means true implies false, my answer is false. Q implies P means false implies true, my answer is true, because there is only one case when your answer is false, and that is true implies false. Now false, true. False implies true, answer is true. But true implies false, answer is false. False, false. False implies false is true, false implies false is true. Again in this case true dominates and I get only one answer false, and that is this. And this is very, very important. That first statement is true and after the sign of implication second statement is false, then only my answer is false. So this is the truth table of implication. Okay, now next is biconditional or equivalence relation, and symbol is this, and I think you know the symbol. This we read the symbol by this I double F, or this is also read as if and only if. I double F means if and only if. Another way to read this is conversely. So the same thing is written here, or another way to read this symbol is necessary and sufficient condition. Necessary and sufficient condition. Now look, that means I can change biconditional by these 4 ways. First way is P is necessary and sufficient condition for Q. Second way is Q is necessary and sufficient condition for P. Third way is if P then Q, if Q then P, and fourth way is Q if and only if P. These all four ways are for biconditional equivalence. Now, the truth table of this biconditional or equivalence relation is, I have written a shortcut here. You just keep in mind that for like cases my answer is true, and for unlike cases my answer is false. Like means true, true, false, false. And unlike means true, false, false, true. Now look, what is written here? P, if I take T, T, this means like. True imply true if and only if true answer is true, because for like cases my answer is true. Q if and only if key Q if and only if P, again that is true if your answer is true. For true if and only false is the unlike case, and for unlike case my answer is false. False if and only if true, again false. False, true. False if and only if true, false because unlike case. True if and only if false, again false because unlike case. False, false, like case. False if and only if false, your answer is true. False if and only if false, your answer is again true. So in this case, two cases will give answer true and two cases will give answer false. No one is dominating here. Okay, now look, few more properties are written here and we are going to use this property. All of you must know that commutative property means just you have to interchange their places. That is P union Q or P disjunction Q is equal to Q disjunction P. You can do this while solving the question. Same for conjunction. P, I can say this P intersection Q is equal to Q intersection P. So this is called commutative property. And for associative property, what we have written here, P, Q, R, and same symbol is throughout, union, union, or disjunction, disjunction. Well, just you have to just replace the bracket. Bracket is in last two terms here, and on RHS bracket is in for first two terms. So therefore you have to just interchange the brackets. So this is called associative property, and you can see here throughout we use same symbol, P intersection Q intersection R, just interchange the brackets. This is called distributive associative property. But this property is very important, that is distributive property. And as you all know, just open the bracket. What we can see here, we are using two symbols here. One is union, another is intersection. Now you have to open. This means P union Q intersection P union R. And that this is called distributive. And you can also apply distributive property on RHS. That means by taking P common, and then we put the sign of intersection, and then we put Q union R. This is also called distributive. We are moving from RHS to LHS. So this is called distributive property. Now this is again very important property. What is it? De Morgan's law. De Morgan's law must have read in stretch chapter. What is De Morgan's? Just open the bracket. Negation of union is intersection and negation of intersection is union. So when we open the bracket using De Morgan's, we write negation P, interchange this union by intersection, and then negation Q. This is called De Morgan's law. You can also use this while we converting RHS to LHS. That means just take the sign of negation common and within bracket you write P intersection Q. So this is called De Morgan's law. Okay, now next, again very very important concept. That means if P implies Q is given to you and you have to make the inverse of this statement, then what we are going to learn from here, that in order to find inverse, you just have to negate the first sentence and negate the second sentence on their own places. There is no need to change the place, just negate the first implies negate the second. What is written here? This is called inverse. just negate at their places. What next is written? Converse. For converse, you just interchange the second p implies q become q implies p. That means second statement become first and first becomes second, using the sign of implication. But this is very, very important, that is contrapositive. For this you have to change their places and also you have to negate them. So you can learn this from this example. If x is to y is 3 is to 2, then 2x is equal to 3y. If I have to find its inverse, then I have to negate the sentence statements at their own places. That means x is to y is not equal to 3 is to 2. I did the negation of first. Then 2x is not equal to 3y. So this is the inverse of given statement. For converse, I have to interchange their places. That means if 2x is equal to 3y, then x is to y is equal to 3 is to 2. But for contrapositive, I have to interchange their places and also I have to negate them. That means if 2x is not equal to 3y, then x is to y is not equal to 3 is to 2. So this is all about this chapter. I hope it is clear to you. These are all the basic concepts of this chapter, and just you have to go through these results and you will be definitely able to solve the question of this chapter, mathematical reasoning. So in order to get latest updates, please subscribe the channel Method Wise and hit the bell icon. Please like and share the video. Thank you.